Welcome to the Data Hall YouTube channel. In this video, we are going to talk about how do we perform a one-way and two-way ANOVA in R. So let's start with the one-way ANOVA, and one-way ANOVA is used to compare means if we have more than two categories. If we have two categories, then we can do t-test, and if we have two categories, whether we perform t-test or we perform ANOVA, they would give us exactly same results. So let's perform ANOVA, and because we have more than two categories, let's set the seed so that we can generate a random data, and when you perform this command along with me, you would have the exact same data if you have used the exact same seed. So next, let's generate the height of different groups. So we have three groups, and we have generated a normal distribution height, 30 observations, having a mean and a standard deviation for these three groups. And let's create a data frame that would contains two variables. The first one is height, and it would contain the height of these three groups that we have generated as in a random distribution using random distribution function. And we would have three groups, that is man, woman, and children. And let's perform this command, and we have this heights data where we have height of different individuals, man, woman, and children's. And we would perform this one-way ANOVA on these three categories. So now we have three categories. We cannot perform the t-test. We would have to perform ANOVA. And the command for ANOVA is AOV. This AOV function, we specify our variable of interest, which is height, and then we specified after the tilde sign, we specify the variable that contains the group information. We also need to give it the data frame that we are going to use, that we have generated over here. Now, before we discuss the results of ANOVA, we need to check the normality of the residuals, or this normal distribution, whether the residuals are normally distributed or not, because that is one of the assumptions of the ANOVA. And for that, let's first extract residuals from this equation. We extract the residuals using the residuals function, and using the Shapiro test, let's test whether the results are significant or not. So let's display the results, and we have the p-value. The null hypothesis of Shapiro test is that the data is normally distributed, and the alternate hypothesis is that the data is not normally distributed. Because our p-value is greater than 0.05, so we accept the null hypothesis, which is that the data is normally distributed. Let's move on to display the results of this ANOVA that we have performed. So we have saved the results into this object called height ANOVA, and let's present the summary statistics of that variable. Now we have different statistics, but what we mainly are interested in is this p-value. Now this p-value indicates, in this case, let's first discuss what our null and alternate hypothesis. So our null hypothesis is that the mean value of all the groups are same. So that means whether it's man, woman, and children, their mean height is same. That is the null hypothesis. And so what we mean to say is that there is no impact of this group on the height of an individual. And the alternate hypothesis is that the mean of at least one of this category is different. That means there is an impact of this group on the variable of interest, which is height in this case. Now, in this case, we get the p-value of 0.05, and we know that if p-value is less than 0.05, what we do is we reject the null hypothesis, which is to say that we are saying that the means are different. So if the p-value is less than 0.05, our conclusion would be that the means are different for these different categories. Let's move to two-way ANOVA. Now the difference between one-way ANOVA and two-way ANOVA is that in one-way ANOVA we only have a single factor, such as in this case we only had these groups that contain man, woman, and children. But in two-way ANOVA, we would have more than one factor. We would have two factors. Let's generate a new data. Let's set the seed, and before we move forward, let me clear our environment. so that we do not have any clutter over here and we can easily understand what's going on. So let's generate this data exam score that would contain 90 observation with a mean and a specific standard deviation. This would be a normally distributed data. Now we have two different factors. One is student's grade in another subject, let's just say, and then we have number of hours of study that person had done. So what we are saying is that students' grade do have an impact on exam score. The people with different grades would have different exam scores, and the people with whether having a low number of hours of study or the student who had done more number of hours of study would have a different exam scores. So their mean would be different for these different categories. So let's generate this categorical data and let's create a data frame that would contain 3 columns: the exam score that is coming from here, the grades, and the study hours that are coming from here. We have created this factor function so that that R can know that these are the factors rather than certain characters. Okay, so how do we perform the two-way ANOVA? We use the same command, that is the same function, that is ANOVA function, and we specify our dependent variable, the tilde sign, and our independent variables separated by this asterisk, which is used for multiplication. And then we have this exam data that we have created over here. If you perform this and show you the summary statistics, we have the summary statistics, we have the p-value of the grades, and it would show the impact of grades on the exam score. In this case, it is greater than 0.05, so we can conclude that the means are same for different grades, and the study hours, the number of hours of study that a student had done, again the p-value is greater than 0.05, so we can conclude that the mean exam score for different number of, either the person had done low number of hours of study or high number of hours of study, would have their mean would be same. So that's about ANOVA. I hope this was useful. Do subscribe to this channel and do hit the bell icon. Thanks for watching this video.